hi, thanks for coming and joining me again in my shop as I keep trying to make some progress with this radio. So I've had pretty good luck. Last couple videos you've seen me fix up a couple of things. The big one being these wires down here that were backwards, of course. That's the big one. But there's still one huge mystery in here that I really want to get to the bottom of, and I think there is a chance that something is still not right in the radio, and I think that's why when I flip this control to the shortwave setting, the radio goes quiet. I think this is the big hint. A few of you have managed to kind of follow along with this problem I'm going to talk about in a minute, but the whole picture is fragmented as I've gone through the videos. I've kind of taken little shots at this particular problem and then wandered off into other aspects of the radio as things develop. So here's the whole deal. When I started on this radio a couple weeks ago, or a week ago, there was a capacitor floating right through this space here. And I took a look on the schematic. I could not identify, this is a capacitor I had installed a few years ago, last time when I attempted to fix up this radio and replace all the paper capacitors. And that's the process during which I made quite a few errors in the radio, which I'm correcting now. Well, that capacitor airborne through here is something I installed. I don't normally install things just on a whim. There must have been something that was driving me forward to install it. I cannot remember at this point why I did that. Early in this series I cut that capacitor out. I haven't forgotten about it, and have continued from there because I could not identify any capacitor that should have been connected the way that one was. And I'm not even sure now as I talk about it exactly where it was connected. It's too many things have happened between then and now for me to keep that straight in my head. So what I'm going to do is I'm going to show you some of the documentation around this issue. It has to do with this capacitor here, which the replacement for this one is a little one sitting up in here that I put in. This is not connected anymore, even though it's still sitting in the radio. And it will also involve this capacitor here. This is the one that the white wires were kind of involved in. So I have the feeling the answer to the question of should there be a capacitor still installed here, and what size should it be, and where does it really go, and what is it there for, all those things I'm going to try to answer. And I think, aside from the two little ones back here I still have to deal with, that will restore the radio to full operation. That's what I think. I personally think, yes, there is a capacitor missing. Yes, it's the reason why the shortwave band doesn't work. Yes, it has to do with the AVC and related to this capacitor. So let's talk about that for a minute. The AVC on this radio. When you're in broadcast, I'll show you this on schematic in a minute, but when you're in broadcast mode on this radio, listening to ordinary AM radio, the AVC is damped by two capacitors working in parallel. When you switch to the fourth setting on here, switch to the short wave, one of those two capacitors is disconnected. Yes, that's the condition of the radio at that point. Yeah, one of those two capacitors is switched out. This reduces the amount of capacitance and damping effect in the AVC. The AVC voltage will then track a varying signal faster. Now think about this. If you're listening to AM radio fades very slowly if it fades at all. Okay, the problems with listening to AM radio seldom have a lot to do with fading in and out. So if you have an AVC that's slow to change, that's probably just fine. If on the other hand you listen to shortwave, the shortwave signals can vary quite rapidly. Sometimes they're literally pulsing like this. I think that's from the signal coming up over the North Pole. I don't know that to be sure. Often shortwave stations are fading very slowly, so a slow AVC can kind of keep up with it. But if they go fast, all of a sudden the AVC can't keep up, and what you start hearing is the volume go up and down. You start hearing that. So you want the AVC to move fast, track with the fast changing. This is my AVC hand, by the way. Oh, did that come across on the camera? Was I just waving my hands in space here for no reason? So that's the deal. Two capacitors, normally both connected on broadcast, flip to shortwave, only one left. That, I believe, is the missing capacitor. I got a suggestion from one of my excellent viewers stating exactly that. And so I think this is the last thing I'm going to have to really hunker down and chase down through this radio. So hopefully this won't get too tedious, but it probably will. So I think the thing to start looking at is, first of all, let's look at the diagram that goes with this radio. And I'm gonna try to get it up on the screen here. If you'll just right on here with us. Let's see if I can pull that off. Just bear with me here. Okay, so there's the schematic showing what I was working on with these two wires. The two white wires from the earlier video are these wires here. These two here. See how this wire connects to this line here, okay, which is the AVC line. There's a capacitor that's permanently there all the time, C38. And this switch clicks in this capacitor for the 3 AM band positions. So we turn this set on, click. So this will be the first AM, second AM, third AM. The end of this little slider bar is sitting here. When you go to shortwave, this connection opens. When it opens, this capacitor is removed, and all that remains is this capacitor. Or does it? That's the question. Is this really there? Or is this missing? Is this the one I cut out? And I mean, it's an easy capacitor to put in anywhere on this AVC line, anywhere at all along it. All I got to do is just drop it through a capacitor to the chassis. So that also means this capacitor can be almost anywhere in this radio. C38. And now, to improve my ability to get confused, I'm going to make notes. And that's going to improve my ability to get confused, because it's just going to be another thing for me to look at. So, but I've been around on this ride quite a few times, and off camera, and it's never worked out for me. So C38 is the question, guy. Now, how big is C38 supposed to be? So look down here on the parts list, pick off C38, here it is here. Look, it's just a 0.01, according to this, 0.01. So that would be the amount of capacitance in the AVC line all the time. And then the other one that we switch in, when I switch to switch out, the one we switch out when we go to shortwave is 28. 28, according to this, 28 is a 0.1, 10 times larger. So basically, throwing the switch to shortwave reduces the damping capacitor in the AVC by a factor of 10. Well, that's a big change. Maybe in the case of this radio, it's a much bigger change because C38 may be missing. Now, here's where things start getting really interesting. Flip over here. Look at this diagram here. You know what I'm going to do? I'm going to try to flip this so it's the same way as the actual radio is. Nope, that's totally upside down. Let's flip again, flip again. Okay, so now this diagram is sitting here on the screen the same way the radio is here in my shop. So now, oh heavens, I'm looking at the wrong thing here. Oh. Make sure I'm looking at the same screen you're looking at. Well, that's good enough there. Okay, so my cursor's appearing, yes. So here is C38. This is the question. Is this capacitor really there? C38. Okay, the confusion's really going to run. C38 in the diagram, the little diagram, the layout diagram, appears to be on the wall, on this wall. So it's not this one, it would be right here. There's nothing mounted on the wall. But just down here is this capacitor. Now this capacitor is the capacitor that's on the end of the wires. Okay. This is the capacitor on the end of the wires that gets switched in and out. Okay, I don't know the size of the one that's in here. Well, maybe I do. So 104. Okay, I don't know what that is offhand. I'm going to figure that out in a second. It's not mounted up here. It's mounted down here. So the one that, and now see, I'm starting to get confused. C38, let me just hang on here. I hope I don't just confuse everybody with me, which is likely to happen. Now hold on tight to your own thoughts here. C38 is not switched. It's C28 that is switched. C28 is supposedly, that was the 0.1, right? Let's double check. And this is actually, been through this so many times. 0.01. C, that's 38. C28, see, that's how easy it is. C28.1, no doubt about it. 0.1. And it's the one that is switched. This all makes sense, leaving a small damping capacitor for shortwave. Get rid of the 0.1, but this isn't a 0.1. Okay, want to get more confused? Let's get more confused. I find it confusing anyway. Okay, so when we look at this diagram again, whoops, let me just get it here. There we are. Never mind C38. Here is C28. Now, I just told you C28 is 0.1. This capacitor right here, which is sitting right here in the radio, is a 4 microfarad capacitor. So, the schematic and the radio do not agree on the value of this resistor, of this capacitor. So, in the radio, in the position of C28 is a 4 microfarad capacitor. Any doubts about anybody doubting why I got confused on this yet? Okay, I'm feeling pretty innocent. Well, let's go even more confusing. C36. Okay, so C36 is a great big capacitor shown airborne in here, shown in the position of the capacitor that I cut out, the little one I cut out, that I didn't know where, I couldn't figure out what it's doing there. C36. So we'll look at C36 on the schematic. A big capacitor. Oh, let's look in the list. Hey, 4. C36, 4. Now here's the thing. There's only one 4 microfarad capacitor in the list. You can look this list up and down. I've looked it up and down numerous times. There is only one here. Yet on that diagram, it almost looks like there could be 2. One here, and this would be a fairly big capacitor here, if it's pictorially accurate at all. It is similar pictorially to this one. Now, if C36 was a 4, and I cut it out to replace it, because back when I was doing this, I wasn't really relying on the schematic much at all. I was simply pulling out a part and putting in a replacement. Whatever was there, I replaced as best I could. In some cases, I didn't have the peculiar, for me, peculiar size capacitor, like a 4 microfarad. I didn't have something like that. I left this one in, by the way, until most recently. A couple of days ago, I finally changed this with a new one, which is sitting up in here, in case you haven't quite followed it. Even though this guy's still sitting there, he's cut off. He's just dead baggage now. So what about this? C36. So we'll go find C36. C36 is supposedly the 4. Okay, let's find C36 in here. We go looking. Aha, C36. C36 is up here. C36's job, this is a ground connection here. That's all this is. So this is just a ground. And it's connected to the B plus really trying to smooth things out here on this wire, which is feeding the triode, which is going into the power amp, you can't afford to have any hum coming into this guy. A little bit of hum is going to be a loud hum coming out the end. So I also want to decouple as much as possible, which is to say any signals which are accidentally traveling on these wires from earlier stages need to be knocked out. So for instance, this guy here, there could be a little bit of signal traveling along here, would get right on in all the way into here. So this guy snuffs it out. So it's an important capacitor. Without him in place, I think this set would have all kinds of wonkiness. Hey, it did have all kinds of wonkiness. So C36 is a 4 microfarad capacitor shown in the middle of space here. If I found a 4 here, which is now sitting up here. This one, this particular capacitor is cut out. This one appears to be not mounted on the wall, but is actually sitting down here on a terminal strip. So it's just kind of left to me to sort this out. I think we should start with 36 as it appears on the schematic. Is it really there? Is it really there? Is that really what that 4 is? So I think the easy thing is you can look, this positive wire comes here, ties between these two resistors. I think I've done this already. I think I'm doing it for the second time. I think I was on my way to doing this and I got distracted. So let's finish it. R11, R12. So off of the plate V4, R11, R12. They are 22 and 222. Those are the 22s. The 22s. They're down here. They're nowhere near up here. Unless there's another couple 22s. Okay, and what are we talking off the top of V4? So V4 is down in here. V4. The 222s. Okay, so there's a wire. This is the point where the 220, the radio's not on, by the way, no power. The 222s tie here, that's their midpoint, and there's a red wire. Red wire comes up here, and comes up the wall here, shows up above. I'm not sure I can get my camera up quite high enough. Okay, shows up above here. You can just see the very top of it. Connects to a terminal point there, which connects it to this 4. So this 4 microfarad capacitor is actually connected at the point where these two resistors are connected. That's exactly the same as the schematic, and the other side is grounded, which is exactly the same as the schematic. So this guy is correctly installed, replacement of this one, which is C36 as per the schematic. So C36, I'm writing in big print, is okay. There, so I won't forget. So now we're back to 28 and 38, and what is going on there? I think in this case, what I'd like to do is, looking at the schematic, is try to hunt for where this capacitor has to be. It's very tricky. I have to follow, basically, follow this wire. Look, these are the two white wires. I know where these are, and I know one of them goes to the capacitor. It's the other white wire ties onto the ADC line. So I can pick off the ADC line, follow it along its length, looking for C38, C38 being a 0.01. C38, according to the diagram, being this this guy right here. But my impression is this guy in the radio is C28. I got it right? Maybe I don't have it right. Yeah, I think this is C28 and C38. Well, let's go hunting. Let's go hunting. Well, let's start here. So here's the two white wires. Here's the white wire I'm thinking C38 should be findable from. Maybe it's right here. Findable. The white wire goes up. The white wire comes along the back here, up here, through a hole. Now you can see it up here. It's the same white wire. It comes up into here. What? That's right. This is one of the wires leading up to one of the grids. And there is a capacitor here put in yesterday, 100 picofarad. That's doing something entirely different. So I would say no, this white wire not getting me there. No finding of the capacitor. Now, what else is coming off here? I get a more serious poking tool here. So easy to be fooled. I think there needs to be a capacitor from here to ground. The only other place to put it would be right from here to ground. It would be electrically the same. Once I move beyond this point, I'm into circuitry beyond where that capacitor should be. So, you know, I think I've already finished. I think that was the end of the story already. This wire is supposed to go in lots of other places. How come I don't see it branching out? And so this would be one branch here, where this resistor is. No need for a white wire. They got the resistor doing the whole job. And the other branch is this white wire going up here. I wonder if it's see there's red wires coming off the other side of this capacitor. So that's probably the rest of the branches. Coming up into here, and this is probably the grid connection here. Yeah, I think that's the case. The way they've done the branching is they've red wire. You know, red wire usually means high voltage. Am I seeing this right? I'm not seeing it right. Okay, so wow, it's just a tiny clearance between this capacitor there and this terminal. So this white wire comes to this capacitor and nothing else. That's what it's supposed to do, according to the schematic. That's a ground terminal. Another white wire here. Hey, you know what? I think I'm going to hook up a capacitor from here to ground. Just need a nice ground point. Somewhere in here. There's one right here. This one right here should do it. Yeah, riveted. There's a point right there even. I could even just go right there. And that's supposed to be the smaller one, the 0.01. Okay, let me get my capacitors ready. I got a plan here. Okay, so I put in the capacitor. You see there, a little capacitor there. There he is. The other capacitor is a 0.1, just as it should be. So 0.1 switched out during shortwave operation. No other capacitor. ADC runs wild because there's no capacitor. Capacitor's in there now. good chance now when I switch this knob to shortwave, the radio will continue to operate. Okay, you can hear me jingling my coins here. What's my bet on this one? Okay, so I'm going to bet, I'm really thinking about this hard, 60, you know what, I'm going to bet 75 cents. That's 3 Canadian quarters. 75 cents. That's about halfway to a cup of coffee. That's what I got running on this. So let's first switch is off, so we know where that's positioned. Volume down, band selector, just to know where I'm starting, is on AM. It's all the way this way. Capacitor's a low risk change, but I'll still start it up with my lights up there. Here we go. Here we go. It's unlike a normal TV studio. You get to see everything. You get to see my monitors, my microphone, all the secrets. Revealed. Here we go. Switch it on. Bang. Here we go. Normal operation on the dim lights. Here we go. Here we go, man. This is it. AM. Oh, it's there already. That's not very reassuring. I got nothing for an antenna. Yes, I do. I have the antenna on the AM. So, ooh, not too sure what to make of that. It's like ticking goes away when you tune in something. Okay, well, so I'm going to switch to, I'm going to leave the antenna on AM. I'm going to switch the band switch to shortwave. Okay, turn it up. So now basically the antenna is connected past the first two. So now I'm going to move the antenna from where it is, this is still on broadcast, over to the proper shortwave antenna spot. Off and on. Okay, that's good. Got louder. That's good. Now we're ready. Switch to shortwave. Maybe there's just going to be a big bang here. That'll be the end of the radio. There we go. Well, that sounded good. The next one is shortwave. It still works. See, it made virtually no difference to the operation of the radio because the AVC voltage isn't going to jump up or down, just switching in and out the capacitor. You know what else is gone? The great big pop. When I switched to shortwave, there used to be a big pop. That's gone now that there's a capacitor sitting there. So really now I know that when I switch between shortwave and broadcast, I'm changing the AVC reaction speed. That's what's really going on here. Because the tonal quality is being changed too, because these three settings are tone settings. So you can kind of hear the tone, a little bit of the bass drop out. Okay, let's see what we can tune in here. I'm on the 6 megahertz band here, so we probably won't find anything. Okay, just go up a band. So this would be 7.3 megahertz in that area. Might get something here. Okay, you certainly hear the AVC action. And what I mean by that is when I'm off station, I still got weirdness in the volume control. Lots of weirdness. Okay, so I'm off station. You hear the hiss as I bring the station in. See the hiss get quieter and quieter? And that's the AVC voltage coming up and reducing the gain of the front end of the radio. That's where the hiss goes. That's how I know the AVC is working.
y que también podían regalarse. De este modo, la familia completa en un momento de la historia pasó como regalo a manos de Margarita de Austria y posteriormente fueron heredados por el niño de esta Alejandro Carmona. O sea, como si fueran un objeto. Sí, extraña como cuando tú tienes un perrito bonito. Animalito.
Sounds pretty good.
Pedro
I
González
like it.
falleció en 1610.
Sounds Spanish to me, probably coming from Cuba. So that's 7. Let's go. Not necessarily though. It doesn't necessarily do. Up another band. This would be 9 megahertz, I believe. 9.5 in that area. All the weird heterodyne, all that stuff is all gone. One of the things I've come to learn about doing this work is when a radio really misbehaves, really does weird stuff, chances are there isn't a wiring error in it. That's not that I encounter them very often. This radio being about the worst. I'm the culprit behind it, so let's go another band. So this would be probably 11.3 or whatever it is. And you should start getting the stuff fairly. That's a strong station there.
As we're taking this on December 8th, now
that's my birthday.
Is up in arms, literally, because President-elect Trump is saying, you guys in NATO are going to have to put your own bill.
And you will find a man.
Yes.
And they're not.
See, just like everybody, I'm being trained to shut up and not be critical. That's what's happening. That's why you hear the anger in my voice? Yeah. Trained to shut up, aren't we all?
And Sunday.
Not this guy, though.
And Monday, which is going to be Passover.
Okay, I'll try to calm down now. Not this guy.
On Monday, we will observe the Passover meal at 8.
My heart is pounding from that little moment there. It's looking really nice. Sounds nice, eh? If I can't leave it there, I'll get a copyright hit. Yes, I get copyright hits from stuff like that. I have to cut it out of my videos. Okay, here we go. I did say something. It'll get me more comments. This is going to be a hot video unless I go back and get this stuff out of here. Okay, here we go. Next one. I'm in quite a mood today. Cuba. Pretty much, if the word Cuba comes out, it's pretty much coming from Cuba. Okay. I've lost track of where we were. We were 11. This would be 15, I think. 15. Next one would be 17 megahertz band. I think I may have booped up here on the bands, but that's okay. See, it get quiet as I go up. I think that's probably an alignment issue. I got an email asking, hey, what about that SDR radio? Yeah, I'm going to be employing it on this for sure. Absolutely. It's just until now, the radio has been discombobulated. There's just no reason to try anything with a sweep generator or SDR or anything. But I think we've reached the point. Okay, one more band. Yeah, now the top band is 21 megahertz, 21 megahertz, I think. Again, I don't think there's anything up here. But that's enough evidence for me to conclude that this radio is running quite well now. I think I got it all sorted out except maybe this tone control. Let's pop back to the tone control for a minute. It's really only intended to be used, I guess, with the AM broadcast band. I guess. So that's what we'll do. We'll go back to AM broadcast. The antenna's in the wrong place right now. That sound could be motorboating in the radio. And that really does sound like motorboating to me. Now move the antenna. Okay, put it where it's supposed to be for AM. What's on this wire? It's coming into this radio. Weird tone stuff. My gosh, what's on the end of this antenna wire? That's a good question. What is on the end of the antenna wire? Let me just investigate that briefly here.
Act as it in.
That's AM. Same sort of deal there, right? Same kind of sound though. Is it possible that this radio is generating that? Very, very powerful, whatever it is. I'm going to cut the power off for this radio and see what happens. Nothing, of course. Let me just tune this back here. .5.
In the right direction when they're looking at protecting their language. Part of the challenge and part.
Okay. They're talking about protecting the language of the indigenous people in Canada. The language is. Well, I have the feeling that everything is working really well here. You know what remains to be sorted out is what is going on with this loop antenna. I'm really not sure what I'm going to do about it. The only information I have is just a very bland sketch on a schematic. Just doesn't really give you any idea how the loop is really built. I haven't found any photographs, any hints, nothing. What kind of loop antenna might be out the back of this? And the question would be, do I need that loop on here in order to establish the proper parameters of the front end for broadcast radio? Without the loop, this radio won't operate properly. Without a proper loop, this radio won't operate properly in AM no matter what I do. Will never achieve the kind of performance it really is intended to. But you know, the bottom line is I will never listen to AM radio with this. I never will. Why would I want to spend my time trying to sort that out, other than just the curiosity of what's going on? Maybe I've faced enough curiosity with this radio at this point. What I should really do is just get on to aligning the shortwave bands and make this guy a hot shortwave radio, which was my intention. AM radio, this guy's never going to do it. And the reason is the location it's going to be sitting in when I go to use it is just bad for AM radio reception because of other interferences. Anyway, so even if I got this radio really working well on AM, A, I'm not going to use it. B, it wouldn't work well even if it is working well, considering where it's going to be sitting in my house, from what I understand about noises and interference and how they are distributed throughout my house. So, okay, so I've logically concluded that what I should do is the alignment process on the shortwave bands, and that's really going to be an exciting and fun thing. I'm going to try to employ all the firepower I can muster in my shop here. or that firepower, unfortunately, will have to be my brain. But as long as I keep soaking it with caffeine, I should be pretty well off. What to do now? So I think I'll say goodbye on this video, and next video will be alignment work, being underdone and underdone. I'm going to underdo some alignment. Okay, enough talking. See you on the next video.